Everybody, this video is going to be covering functions, function notation, and equations. Now, most of the time when we say the term function and equation, we're going to be talking about roughly the same thing, but they don't have an exact same definition. So right away, I want to give you a definition of each and show you how they're slightly different. So the first definition we're going to talk about, because we're going to focus on it even more here, is a function. And a function says that every input has exactly one output, and that exactly one is very important here. By definition, if an input, so you drop in the number 3, and it gives you more than one output, that means it is not a function. So the difference between a function and an equation is that an equation usually has exactly one answer. A function, by definition, has one answer for each input. So for a function, if I drop in the number 2 and it gives me 6 as the output, that is one possibility in the function. But then I can drop in a new input and get a different output. An equation, by definition, usually has one answer. For our purposes early, though, they're going to be basically the same. Let's go a little bit more into detail on what we're talking about when we say the definition of a function. So for example, if my function has the input of 8 and I drop it into the function, which we'll show you how to do in a little bit, and it gives me the number 4 as an output, that means the function is going to be written as having 8 as an input and 4 as an output. And if you've done any graphing before, you notice that this is a point on a coordinate plane, or this is an ordered pair, and that is on purpose. As with most math, all of these skills are interconnected. Another example is if I drop in the number 6 as an input and it gives me, let's say, 33 hundredths as an output. That means the ordered pair, 6 and 33 hundredths, would be involved in that function. Now, something is not a function if I take an input, let's say -1/2, and it gives me multiple outputs. Let's say it gives me 8, 10, and -6. Since this is not exactly one output for this input, that means whatever this came from is not a function. Another way to think of it is I like to think of functions as being a machine. So the idea is I take a number, let's say 3, and I drop it into the function machine. Once it's in the function machine, it gets stirred, it gets shaken, it gets moved around, and it changes into some other number, let's say 6. And because one single number came out of the function machine when I dropped in the 3, that means the ordered pair would be 3, 6. Once again, being one input, exactly one output. But now we're going to get a little bit more mathy with our definition here. We're going to start calling inputs some variable. The most common variable we use in math is x. You don't have to use x. You can use any variable, but x is definitely the most common. Then the output is written as f of x. That's how you say that. So input is a variable. The output is the function with that variable in it. And now let's talk a little bit more about what that f of x really means. So we have f of x. And so we say that as f of x, which actually means the function that uses the variable x. So if we change the function notation a little bit and we say f of a, this would be the function that uses the variable a. But that's not all we can do with this notation. We can even change the f of to a different letter as well. So f is a function, g is still a function as well. So this is still a function, but this one will be a function that uses the variable y. So usually when you see f of x and then later you'll see g of x, it really shows that they're different functions. Okay? So the function notation might seem a little bit new to us, but it's actually not that scary once we can get comfortable with what it means. So what we have up here is we like to think of this as two split sides of a function. Now, I would also be okay using the term equation here, but since I see f of x in it, I usually say function for this example. Let's make sure I'm on the pen. But I would not count it incorrect to say this is also an equation. So we have the function that uses x is equal to 3 times whatever x is plus 4. So our x is our input, and then f of x is our output for each. So what if we wanted to use, let's use blue here. What if we wanted to have x is equal to, let's say, 5? So what that means is we take this number 5 and we substitute it into our function every time we see an x. So we change this into f of 5, which means the function that now uses 5 is equal to 3 times 5, because that used to be our x, plus 4. Well, 3 times 5 is 15. We add 4, and we get 19, which means we would write our answer here as f of 5 is equal to 19. And now that input can change at any point. So I'm going to erase the line over here just to give us a little bit more room. What if I wanted to use the input of, let's say, 9? Okay? So now, once again, every time we see an x, we're going to substitute a 9. So I get f of 9 is equal to 3 times 9 plus 4. 3 times 9 is 27. Plus 4 is 31, which means f of 9 is equal to 31, and that's our answer. If we wanted to write these as ordered pairs, we would go back to each of our numbers. So our input was 5, and our output was 19. That would be the input-output pair, and over here it would be 9, 31. And that's really the entire concept of function notation. We can get a little bit different with it. Maybe instead of using function notation, now we use a second variable. But it's still the exact same idea. Our input is going to be our x, and our output is going to be our y. Now, because this doesn't use function notation, it doesn't have f of something, this is usually where I use the term equation. So if you notice, when you have function notation, I usually say function. When it has an equation notation, like this, I usually say equation. For now, they're basically interchangeable. So just like before, we want to know when x is something, what is the y equal to? So for our input, let's use a fraction. Let's use 1/2 for our x. So we're going to treat it the exact same as we did before. Every time we see an x, we're going to substitute 1/2. But this time, there's only one x in our equation to substitute. So I will write y equals 2 times 1/2 minus 18. Now, 2 times 1/2, or 1/2 of 2, is equal to 1. And then I'm going to take away 18. Which means our answer has to be a negative number. Well, 1 take away 18 is negative 17. We can write this as an ordered pair, just like we did before, by writing 1/2 and then negative 17, which before we said this was our x and our function that uses x, but now we can say it's our x and then our y, which is probably what you'll see a little bit more often. Now we can do a new input. So this time let's do our x is equal to 10. And let's figure out what our y is when our x is 10. So just like before, we substitute 10 every time we see x. So I'm going to say y is equal to 2 times 10 minus 18. Well, 2 times 10 is 20. Minus 18 means our y is equal to 2. So our input-output pair, or our ordered pair, will be 10, 2. And that's the basic idea of function notation. If you have any questions, please let me know at any point. If you need help with some more examples, there is the retake video, which I'll be recording in a few minutes.